All right, today is talking about perimeter and circumference, Unit 5, Day 2. Our objective is I will be able to determine the perimeter and circumference of 2D shapes. So first, when we talk about perimeter, we're talking about the distance going around an object, right? So in this case here, for this square, we would look at going all the way around this figure. In order to find the perimeter, we would add together all of the side lengths. Okay. Now, very similarly, the circumference is just the perimeter for a circle, specifically for circles. And in order to do that, we are given this equation, circumference equals 2 pi r. So if we know what the r value is, our r being the radius, then we can solve for the perimeter. Now, our first teacher example asks us to find the perimeter of the figure below. So we just need to add up all of the side lengths, right? So we would add together, here's my starting point, 6 plus 4 plus 2 plus 3. But you'll see that we're missing 2 side lengths here. So we need to add 2 more numbers. And we need to figure out what those values are. In order to do that, we're going to look at this length right here. We know it's 6 centimeters. And what you can see is that this missing length here and the 2 centimeters here equal our longer 6 centimeter section, right? So this section here being 2 centimeters, then we can figure out what equals the remaining, right? So 6 minus 2 gives us 4. So this section is 4. That tells us our mystery length here would also be 4 centimeters. Using a very similar logic, we can figure out what our missing length here is on the other side. We know that this section is 4 and this section is 3, which tells us this is going to be 4, this section will be 3. So we can add those together and we get a total of 7, which tells us the missing values are 4 and 7. Okay, and when we add up all of those values, we get a final perimeter of 29 centimeters. Go ahead and try student example number 1 on your own. For teacher example number 2, we see that we have a circle and it's asking us to determine the circumference of the circle below, rounding to the nearest hundredths. So we can see that the radius is 5 centimeters, right? Starting from the center going out, if our radius is equal to 5, and we plug it into our equation, 2 times pi times 5, we're going to plug that into the calculator, and you'll get 31.415926, so on and so forth. Because it says round to the nearest hundredth, we want 2 decimal points after our decimal. So 31.4, and then we have a 1, but the number after that is a 5, which means you have to round up to 2 centimeters. Okay. Try student example number 2 on your own, please. Okay. So some of the problems, like the first teacher example, does not provide us all of the side lengths. So we have to use other techniques sometimes to find out what those lengths are, right? One of those strategies may be using the Pythagorean theorem. So if there is a slanted side, right, like this side is slanted as opposed to strictly vertical or horizontal, then it's a clue maybe we would try to use the Pythagorean theorem. So let's take a look at teacher example number 3. Determine the perimeter of the figure below, round to the nearest tenth. So I'm going to start by thinking, which side length do I need to find out? I need to figure out this slanted side length and this vertical side length. Now I can tell that the bottom section is a rectangle because I have all of those 90-degree angles. And if I know that this section on the right is 5 centimeters, then this section should be congruent to it, which will make this also 5 centimeters. Okay, but the slanted side, because it's not strictly vertical or horizontal, we need a little bit more information. All right, so can we use a Pythagorean theorem? Well, not quite yet, because we still need a little bit more information. In order to use the Pythagorean theorem, we need to know what two of the side lengths are. So we can figure out what that bottom side leg is because we know that the bottom of the entire rectangle is 8, which tells us one section of that bottom length is equal to 2, one section is equal to 1. That means the remaining of that 8 is 5. 1 plus 5 plus 2 gives us 8. So we know that the bottom leg of our triangle here is 5. The other leg is 5, which means we can solve now for the hypotenuse. So this is going to be my A, 5 is also B, and then C is what we're solving for. So we're doing 5 squared plus 5 squared equals C squared. I'm going to take the square root of both sides. And we get 7.07. Okay, now we have all of the missing sides. We just have to be careful that we're only adding up the sides that make up the perimeter. We're making up the outside section. So I'm just going to, as a reminder, highlight what the outside sections are. And we're only going to add up the numbers associated with each of those side lengths. I'm also going to mark where I'm starting counting. Okay, so I'm going to start by counting the 7.07. So 7.07 plus 2 plus 5 plus 8 plus 5 plus 1 plus 5. And I can double check. How many numbers do I have? 1, 2, 3, 4, 5, 6, 7. And how many sides do I have? 1, 2, 3, 4, 5, 6, 7. Okay, if those numbers don't add up, then maybe you're doubling up a number, or you're doubling up counting a side, or you're counting a side that is inside of your figure instead of around it. Okay, like you'll see, we did not add this 5 here because it is inside and not a part of our perimeter. Okay, when we add up all of these numbers, we'll get 33.07. Round to the nearest tenth, then we'll have 33.1 centimeters for the perimeter. Okay, try student example number 3. And when you're done, don't forget to do your reflection.